Hello, students. This is Professor Shan Hu from the Department of Mechanical Engineering at Iowa State University. Today, I'm delighted to present building batteries with stuff in your kitchen together with my graduate student Yifan Zhang. Batteries are everywhere in our life. We can find them in toys for babies, in a car running on the road, or even airplanes flying in the sky. And batteries appear in different sizes and shapes. So I'm going to give the stage to my student Yifan and then let him show you how he built a battery that can be used to light up an LED light using stuff that can be found in the kitchen.
Hello everybody, welcome to the lab. This is Yifan Zhang from Mechanical Engineering in Iowa State University. Today I'm going to show you an easy experiment of how we can make some batteries with simple and commonly used stuff in the kitchen. So let's get started. So first, I prepared some aluminum foil and copper foil, and I cut them into pieces so that we can assemble some batteries later. And also I prepared some activated carbon, which you can find them under the tap. And the Coca-Cola here is a electrolyte. And also I have some paper towel to use them as a separator to avoid two electrodes connected to each other. The voltmeter here is to measure the voltage between two electrodes after we assemble the battery. And also I have a kind of LED bulb so that you can see some amazing stuff as the experiment goes on. So these are the items and the tools we need for the experiment. And then let's start assembling the battery. First, get a piece of aluminum foil and put it under the bottom of the bowl. And then get a piece of paper towel on the aluminum foil. On top of the paper towel, let's just pour some activated carbon on it to play it as a conductor. And then use a pipette to get some Coca-Cola onto it. So make sure to wet all the way so that you can just make the conductivities as good as possible. And then put a copper foil onto the activated carbon and the paper towel. And finally, with these, we finish assembling this battery. After that, we take the voltmeter out to test the voltage between two electrodes. You can see a red pen and a black pen connected to the voltmeter. And the red pen here is to be pinned on copper, which is the cathode. And the black pen here is to be connected to the aluminum foil, which is the anode. According to the number on the voltmeter, we can see the voltage between two electrodes is approximately 800 millivolts. So the next part is to build two more batteries with the same methods and stacking order as the first battery I made. Then we use the red pen tapping on the third copper foil and the black pen on the first aluminum foil. According to the voltmeter, the voltage now is about 2 volts. So basically, if we stack the batteries to make them into a series, the voltage will be the number of batteries times the potential of each single battery. So theoretically, the voltage of a series of 3 batteries would be about 2.4 volts. If we treat the potential of each battery as 0.8 volts, which is the number I showed you in the measurement of the first battery, but actually there are some loss due to the contact issue or other factors which may cause the increase of resistance. So as you can see, for a stack of 4 and 5 batteries into a series, there would be also some voltage off from the theoretical value. So if you want to build a battery on your own, make sure the flat surface, such as the aluminum foil, copper foil, and the paper towel, will well contact with each other. As I told you that I would like to show something with the LED bulb, so I need to get the voltage from the battery about 3 volts. So with the same assembly methods, I made the stack into 6 layers. And then achieved a voltage about 3.3 volts. Finally, let's turn off the lights and something will happen. Simply just connect the green and yellow wire to the copper and the aluminum foil respectively. You can just easily light the bulb. Well, that will be the end of this experiment. I believe you can make the battery by yourselves. I hope you enjoy it, and thank you for watching.
Okay, welcome back. I'll take the stage. After Ifan show you how he made a battery or a stack of batteries using stuff you can find in the kitchen. Let me briefly explain how one battery cell works in the experiment that Ifan just demonstrated. In the experiment, Ifan showed you that he used a copper foil as the cathode. In other words, it's the positive electrode in the battery. And you can find copper foil or similar copper conductor in your kitchen, such as the copper mesh scrubbers that you can find in the grocery store or even in your kitchen. And then next, he takes some active carbon from the used water filter that you can find in your water pitcher. You could also find active carbon from grilled charcoal. And you can grind them into powders, so they work in the same way as the active carbon powder you find in the water filter. Next, he took a piece of paper towel, and the paper towel you can replace it by facial tissue, but paper towel is more absorbent than facial tissue, and it can absorb more electrolyte, and which will work to the advantage of the battery. Finally, he took some aluminum foil as the conductor at the anode, in other words, the negative electrode of the battery, and that's all the material that you need. Oh, I forgot about the important electrolyte, the coke. After he assembled all the layers, he then wet the paper towel with the coke. And that's it. That's all you need to do with one cell. Let me explain what happened in this one cell. The electrolyte, which is the coke, contains phosphoric acid. And the phosphoric acid is going to produce a positive ion called a proton. At the negative electrode, the aluminum foil is undergoing a reaction that's shown here. This tells us that the aluminum foil is going to be converted into aluminum ion that could be dissolved in the electrolyte and some electrons. The electron is then going to move through the external circuit and do work. For example, it's going to light up the light, or turn on the fan, or turn on the engine, etc., doing work. And then the electron is going to return to the positive electrode, where the copper foil and the active carbon is. At this positive electrode, the proton that you found in the Coke then will take the electron coming from the aluminum and doing work and turn the proton into a gas called hydrogen gas. So you won't be surprised to see some bubbles coming out from your battery that you made using this method. This bubble could either come from the carbon oxide in your Coke, or it could be the hydrogen gas that was generated at the positive electrode. So this is what's happening in one cell. As Ethan explained to you, you not only need to build one cell, but you also need to build more than one cells and stack them together, or in other words, put them in series so that we could achieve a voltage that's high enough to light up a red LED light. And this is what he means by connecting the cells he made in series. He means that you need to connect the copper foil, which is the positive electrode, with the aluminum foil by pressing them together. And you do the same thing for connecting the negative electrode aluminum foil with the positive electrode copper foil for the next cell lying right next to the first cell you made. Notice or not, you might have already connected batteries in series before. If you open the battery compartments in your toys or in the TV remote at home, you might notice that the terminal of the battery that's labeled positive sometimes is connected to the terminal of the battery that's labeled as negative. And this way, the batteries are connected in series, and we're going to get an output voltage that's larger than the voltage of each individual batteries in the stack or in the series. In Ethan's experiment, he stacked 3 cells that he made and get an output voltage of 2 volts. But when he stacked 6 of them, he was able to get a voltage of 3.4 volts and use this voltage to light up a red LED light. By the way, you can actually find such a red LED light from your Christmas lights. So my question to you is, why the voltage of the stack of 6 in Ethan's video is not twice the voltage for the stack of 3 cells? The answer is that those battery cells are handcrafted by Ethan, so there's not enough consistency during the manufacturing process that makes sure each cell he made will carry exactly the same voltage. That's why the voltage of 6 cells is not simply 2 times of the voltage for 3 cells. But in battery factories, the manufacturing process of batteries are highly standardized and it's operated entirely by machine. It greatly reduced the variation during the manufacturing process, and hence they could produce almost identical battery cells with identical voltages for each cell. And so when we connect them in series, the output voltage could be very close to the number of battery cells multiplied by the voltage of each battery. So this is the end of the presentation. Thank you for your attention, and hopefully you had a great time watching our video and presentation. Bye!